Right, so this is interesting. What I've done basically is I've imported the output and then messed with it a bit. So what I've done basically is, okay, let me just let's make these the same. Yeah, that's it. Yeah. Right. So all I've done is basically the this is generic, and basically what I've done is I've separated the bracketed value. Yeah, which that's currently showing like 10, and at the time it was showing 8. Okay, V2 is the bit that's in the brackets, and then separately I've actually calculated the voltage of the cell C. First one I call 0. Okay, so the ADC is actually reading the cell voltage, and then the second one is C1, which is currently on like 4.1 in this graph, and then C2, which is the one that I actually added in later, which is the one that's a little bit suspect. It's a bit blebbed. Okay, and it's obviously started off at a volt here. I think I measured it at 2 point something, didn't I? I don't know. Anyway, so there it is, right? And when I come to plot it, and I'm seeing this kind of weird, what the? And I'm like, what's going on here? These two look like they're not changing, and this one looks like it's actually changing. Yeah? Apologies if it's gone out of focus. I don't know why it's done that. I think it's because it's the wire of the whatever they call it. Anyway, so there we go. Okay, it seems to be changing. It's because I'm taking a picture of a screen, no doubt. So you can see that. Now what this is, and I didn't realise it, is this is the last cell, the one that I added in. Series 3 is this one. And I'm looking at it because I'm like, what the fuck is going on here? And then I look at it and I go, look at the value, it's going up. You're lying to me, graph man. And it is going up, of course, yeah. And now we've got the final ones, which is 3.4 on the first cell, 4.2 on the second, and 2.8. Okay. 4.2 and 3.4 there, and this one is currently at 2.8. That's the final voltage. So the yellow one is the last one that I added, and it was crap, and so yes, that one is increasing, and it came from low. And what I connected, obviously you can see that's when I turned on the charger. There you go. Now the other two are actually in reasonable condition, so you're not going to see, unless I exaggerate the actual graph, you're not going to see where it's at. But really the noise is going to be interfering with whatever we see. Now obviously here, what we got? So that's at cell, at row number 128. So if I go here, row number 128, there, nearly there. Okay, somewhere there. You will see a slight step in the voltage change. Will you stop going out of focus, man? Right, and I think I don't know, but these lithium cells are actually pretty good at stability of the voltage stability. So that's why it's like a line, because that's the whole point. That's what lithium cells are good at. This one's a shitty one. So, and these are cells, not batteries. And so this one is showing, and it's leveling off. Right now we're currently on. Okay, so the voltage, the constant voltage I set the power pack to is 12 volts. I'm also setting it at 1 amp charge. Right now it is not going to this is the point. You see, you can see how these lines are different. They should be together. Yeah. This is the cell voltage, and those should be the same voltage, right? And the problem is they're not, right? So what's going to happen now is this will then charge it up to the 12 volts, right? But only one of the cells, this one, is actually going to be anywhere near fully charged. In fact, it'll probably be slightly it'll be over the voltage I'm setting at, which is 4 volts, right? And it's currently actually above that anyway, isn't it? Because look at it. And in fact, I'm going to have to reduce it because it's currently at 4.2, which means it is actually fully charged. I don't think it is. We'll check it now because I've actually got this on it. Right, so get off. Right. So let's check the actual voltage. Right, so 3.6 right? And then what's this one? 3.9. So that's okay. You know, it's not over 4. And then we've got this one, haven't we? This one's the Duff one. Okay. Oops, sorry. Yep. Yeah, 3.2. Okay. So none of them are actually outside their voltage range. Right. So 3.2 is the lowest, right? Which essentially means that this guy, right, this is 3.6, yeah? Yeah, 3.6. So this guy here, the middle cell, is the one that's the most charged, right? And it's currently at 3.9. Now, if I actually add up the voltages now, right, we got, let's do it. So that's 3.6, right? And then this one was the last one was 3.2. Okay. So kind of what I'm trying to get to is when this is registering 12 volts, what's going to be across that middle one? Now I'm presuming that they're all going to charge and raise to the same sort of voltage. So basically this one's, oh, it's negative. Oops. It doesn't matter. I just got the terminals wrong. Right. So this one's on 3.9. So this one is so the lowest one is 3.2. This one is at 3.9, right? So if they all linearly increase in voltage, right, which it won't, I think this one's going to increase the most. But if they all linearly increase in voltage, then that means this one is 0.7 volts above. Will you stop it? 0.7 volts above this one. Yeah, so there's a difference of 0.7 volts, right? So essentially what I'm trying to get at is when this is hitting 12 volts, potentially this cell in the middle, it's not the right calculation, but what we're saying in essence is we're saying it's supposed to be at 4 volts when it's fully charged. So potentially we could have this one in the middle at 4.7, which is going to fry it. You see, so that's the problem that you've got, and it's not. What you're trying to do is get to the point where we're all the same voltage, and I don't know what the voltage. It depends on the voltage curve itself. Now, it's not going to be 0.7. It's going to be like 0.3 high. So this one's probably going to be something like 4.3, which means the voltage that I'm setting at is too high because it's going to cook it, and I don't want it to do that. So what I might do is, in order to make sure that we don't damage the batteries, yeah, I'm going to take it down to 11.5. So the combined voltage will then rise. So we'll basically, I'm assuming that what we're going to do is put 0.5 volts, which is going to distribute across all three. Now if it was 0.6, that means it would be 0.2 each. So it's basically going to make it safe. You know? But it'll carry on putting current in until the pack now reaches 11.5 volts. But you can see the issue here now. I'm not doing it right, I know, and I'm not getting calculations right. I know that too. But you can see the underlying issue is that we have, and it's actually revealed in the graph, even though the values are wrong, it's still saying this one is not the same voltage as this one, and that's not the same voltage as this one. Right? So the monitoring system is working in that sense, right? The calibration's wrong, but the system is working. This one here is the middle one, isn't it? Series 2. This is the middle cell, and it's obviously high, which is what we're seeing on the meter as well. Okay, and this one is the lowest, which is the third one, which is what we're seeing on the meter as well. So it is showing, and these lines are not bad. You know, they're not all over the place. They are obviously showing the difference between the voltage, right? It's just that the calibration's wrong. So what it'll do is, if we actually use this circuit to try and balance them, it will get the right. It will get the all we're doing with a cell balancing circuit is we're saying which one are we going to charge, right? And so obviously this will then pick this one, right? The one with the lowest voltage. Charge that bugger. Get that one up, right? And you got to decide when it's charged. Okay, so we're talking about. We've got to make it so it's all the same. So what you do basically, if I was doing a cell balancing, is we would calculate the voltage across the entire pack, which currently right now is 11 volts, right? So 11 volts divided... Alright, let's do it. 11 volts divided by 3. This is how I would do it. Let's get a calculator. Don't know why people go for online calculators. All computers and all phones have a calculator, so why are they... Right. 11 point... It's 0. It's 11.0. Right. Divided by 3. Oops. No. 3. Right. So that's the voltage we should be aiming at, which coincidentally is the voltage of the first cell. Right. But the reason why is because in actual fact that one is at the pack voltage. So what we're really aiming for is that. So this is giving us the voltage that we should be aiming for. Right? So if we were to actually use a battery management circuit, what we do is we'd now say, well, this one's low. Right? So charge that until it gets to the voltage, the average voltage of the pack. Right? Now, the thing is, of course, is if you're charging that, then the average voltage of the pack, the total voltage of the pack will change because you're going to be discharging it. So you need to recalculate that each time, right? And of course you can do that because you've got the pack voltage here. That's the actual pack voltage, right? So you know what the pack voltage is, and you just divide it by 3, and that gives you the voltage that you're supposed to be aiming for, at which point you cut off the charge, right? So that's how it works, right? So you'll focus on that one, right? And keep going until it hits the average pack voltage. And then you're right, okay, we're done. Right? Switch that one off. We're done. We're charged. We balance that cell, right? And then what you do is, right, well, what will probably happen is that this one here now will be, because presumably you brought this one up to this voltage, the average will be moved. It will have moved, right? And so what you do is you say, okay, presumably you just charged this one and brought it up to what the new average should be, right? Which is obviously readjusting each time as the charge goes along. So this one is essentially going to get left behind. So then this one will then be below the voltage. This one will then be low in the pack, right? So what you do then is you then switch your charger to that one and bring that one up to the average, all right? And then presumably it'll change again. So you keep going until eventually all 3 of them are balanced. And at the same time, this one will be discharging because it's transferring the charge. So this one will come down. So presumably at some point, if you keep iterating through that, you will then get to the point where they're all at the same voltage. That's the theory. Obviously, in practice, you need to make sure the calibration is correct, or else it's not going to end up like that. Okay? Yeah. But what you can do is you can do that. You can basically you just focus on one cell at a time, right? And go round until you've ended up with them all at the same voltage. That's how it will work. Battery to cell sort of thing, right? And I would say stay on the same cell until that cell reaches the average, right? And then switch to another. Okay? And you basically keep going around this, okay? Now, my other problem is how to actually implement that. Yes, we can use one of these, and yes, we can then put a buck converter on it, which I believe I have, and if not, I can get one. On the other side of this, to drop the voltage, the output voltage here, which is 15 volts, down to 4 volts, right? Or 4.2, whatever, maximum voltage of the cell. This is the target voltage. It's still above that, you know what I mean? Because that's actually 3.9. So, you know, so we can set that, but then that I can connect that to one of the cells permanently and say, okay, do that one, and just connect it just for a test to connect it to the end cell to see if the software actually does balance the voltage on that cell. But the problem is what about the middle cell? Sorry, not the middle cell, because that's the highest. What about the first cell? So how can I get this right to be? And I can use relays or something, but that's just shit. Okay. The better way actually is to replicate this circuit for all the cells. Now for a 3-cell pack, okay, that means you have 3. But if you got down there, I've got a 39-cell pack. I'm not going to buy 39 of these. No, it's not the way to do it. Yeah. You need some way of basically switching what the output is. But it has to be isolated. I guess an optocoupler would do the job. And you could have two optocouplers, one on the positive side and one on the negative side. Optocouplers are cheap. They're certainly a lot cheaper than these things. It's a lot cheaper than that plus a buck converter. Yeah. And what I would do, of course, is I would actually design a circuit to do this. There are circuits that do this with FETs and diodes, right? And you can, I guess, use an optocoupler like this on a FET, but then you're back to, well, we're going to have one for each FET. So, no. Anyway, I'm going to have to think about that. But it does look cool with the LEDs, doesn't it? You have to say that. Right, so obviously this is the one that's the vulnerable one because that's the highest. But if I drop the voltage back down to 11.5, then I'm presuming that that's 11.6, I suppose. Well, all right, let's put it this way, right? If it's an equal voltage rise across all of them, which it actually won't be, this one will probably have the biggest voltage rise. Okay, so it won't be this one. So I'm quite safe with that. So what I think I'll do, that's actually almost 4 volts, right? So I can raise it probably, if it's 3 cells, and you're presuming it's an equal voltage increase all across all the cells, right? Then you're talking about 0.2 volts, right? That, to be honest, that's actually the voltage I actually want. That's the target voltage that I want for the pack. Each cell should be at 4 volts, right? So I don't know, but that might slightly overcharge it. The problem I've got right now is I want to go home for the weekend. I think I should just turn it off and be done. Yeah. Alright, let's turn it off and be done. I need to watch it, basically. If things get warm, I've got a problem. I don't have any thermals on it. Okay, so let's shut off the current. Right. Okay, it's dropped to 10.9. And we should be able to... okay. So that's very stable. Look at that. Wow. This one is not quite as stable, but it's stable enough. Yeah. Oh yeah, it is actually, and you can see it's dropped. And then we got this one. Yeah. So while we're watching, move that out of the way. Hey, that's it. 10.58 has now dropped to 10.54. Yep. Okay. What's the actual voltage? Get off. Oh man. Okay. Right. So the actual voltage across the cell now is 3.28. Yeah, you don't actually know. It's the difference between these two, essentially. Right? Which, according to this... Well, that's 7.6 and that's 10.5, so it's 3.1. Sorry. No. It's 2.9-ish. So it's saying it should be 2.9 volts. What we actually got? 3.2. There you go. Yeah. So that's reading low. Again, we've got the difference between these two, so that's 7.6, that's 3.4, so the difference is actually 4.2-ish, isn't it? Yeah, so that's reading high. And then you got 3.4 on that one, which is actually 3.6, so that's reading low. So this one's reading excessively high, and this one's reading slightly low. No. Yeah, it is, because that one is 3.2. Yeah. Oh, fuck. No, don't do that. Shit. Sorry. I'm draining my thing for the... this is my... resin printer, and I'm draining that because I want to put that back into the black, because I actually want to put some grey in there, and because I've got some cheap grey, So I'm going to make some prints like those, but I'm going to do them in grey. It's grey I haven't tested yet, but I need to obviously empty that of the black and then clean this, which I do every time for every print anyway, so it's no biggie. I guess I'm done.